Good morning, students. Today, we're going to continue moving on into our geometry unit by talking about the perimeter of something. So today, we're going to go over what the definition of perimeter is, how to solve for perimeter, and then we're going to look at some examples of how we find perimeter. Now, perimeter is something that you may have experienced before in your previous math classes. We are going to talk about how equations can be used with perimeters because sometimes what may happen is they don't give us all of the information. Maybe they'll actually tell us what the perimeter is equal to, and we have to set up and solve an equation in order to figure out what is the length or what is the width or what is the missing piece of the problem. So the first thing we're going to do is let's talk about the definition of perimeter. So the definition of perimeter is it is the distance measured around a shape. So the distance around a shape. So a lot of times perimeter is used for things such as, if we're trying to build a fence around our yard, we need to figure out how much fence we need by finding the perimeter of our yard. Or for example, in a particular room in your house, you may need to figure out how much of a baseboard you need to put around, all of the walls in your house, which means you would need to find the perimeter of each room in order to figure out how much you need. So the way that we solve for perimeter is actually just a pretty straightforward process. So the way that we are going to solve for perimeter is we're just going to add the sides of the shape, specifically if it's a polygon. So polygons are where the shapes have straight edges versus like a circle that has like a curve. So in a polygon shape, we're just going to add the sides of the shape. So I'm going to write that. Add the sides of a shape. And in parentheses, I'm going to put polygon. When we're looking at something such as a circle, there's a specific formula we use called the circumference to find the perimeter of a circle. So for a polygon shape, such as like a triangle, a rectangle, a trapezoid, anything that has like straight edge sides, we are just going to simply add up all the sides of a shape. So let's look at some examples. I'm going to try to use a different color for each example, so that way it's easy to see which is which example. So the first example we're going to look at is a triangle. So they give us a triangle with three sides of 6, 5, and 10. There are no units on this particular triangle, so we can just assume, it's just going to be whatever unit we want, centimeters, meters, whatever we can think of in our head, or we can just say units. So in order to find the perimeter of this triangle, so P, which also is a way that we can abbreviate perimeter. If you see the variable P, when it comes to geometry, it's talking about perimeter. So P is going to be equivalent to 6 plus 5 plus 10, adding up all of the sides of the triangle, which makes 21. And when we have our units, when we are finding the perimeter is just one dimensional because it's a distance. So we just say 21 units of whatever it is that we are talking about. So if it's centimeters, it'd be 21 centimeters, or it would be 21 feet, whatever the unit is that we are talking about. We don't know what the units are, so I'm just writing units as our units. Okay, let's look at a second example. This one, they're going to give us a piece of information and we are going to fill in the missing piece. Okay, so here's our second example. They give us a rectangle, or maybe it's a square, but it's either a rectangle or a square. And we can see that the top and bottom are the length of X. And the length here is going to be 70. And over here, they said the perimeter is equivalent to 200 centimeters. So we can assume that the units are centimeters. They didn't label it over here, but we can assume based on what we know about rectangles and squares that the opposite side is going to be the same length. And that these are forming right angles in their corners. So if the perimeter is equivalent to 200 centimeters, I know what my length is, but I don't know what my width is. So clearly in this problem, I'm trying to figure out what my width is. So the way that I can set up this problem is, okay, I know perimeter of 200 is going to be equivalent to, if I add up all my sides, so X plus 70 plus 70. And to solve this problem, I'm just going to combine my like terms and solve the equation. So 200 is equivalent to 2x because this is 1x plus another x. And then if I combine my 70s to 140, And then if I solve this equation, I am going to subtract 140 or use the ESPO property to try to get x by itself. So now I have 60 is equivalent to 2x. And then to get x by itself, I am multiplying 2 times x. So I'm going to use the depot property to solve. And I get x is equivalent to 60 divided by 2, which is 30. And our units are centimeters. So the distance of the width of this rectangle is going to be 30 centimeters. And if I was to go back and plug that in and do 30 plus 70 plus 30 plus 70, that should make 200. So this is a case of where they tell us what the perimeter is, and we have to set up an equation to solve. Let's do another problem kind of like this one here where we have to set up an equation to solve. But now we're going to relate what we know about area. And even though we haven't gone over a video of how we find the area of a particular shape yet, hopefully you guys all understand how to find the area of a rectangle. If you don't, I'm going to put the formula in the next problem. But the last example we're going to look at is another rectangle example. But in this problem, what we're going to do is we are going to try to figure out, okay, we know that the width of this rectangle is going to be 5 units, and then the length of the rectangle is 2x. So they tell us that the area is equivalent to 100 units squared. That just means like 100 units to the power of 2, because anytime when we're multiplying, if we multiply the same unit times itself, it's like it's squared. We'll get a little bit more into the semantics of that in the area video. But if they tell us the area is 100 units and we have this information, now they want us to find the perimeter. So we're going to take this area formula to kind of help us figure out what is the length or what is the value of x, and then plug that all into what we know about perimeter to find the perimeter. So the area formula for a rectangle is taking the length times the width. So I'm just doing LW, or L times W. So in our particular rectangle, our length is typically the longer side of the rectangle. So our length is 2x and our width is 5. So if I plug in the length and width from what they give me in my rectangle, that means I'm going to have 2x times 5. And we don't know what x is yet, but we know that this can simplify. So 2 times 5 is 10. Or just 10x. And so area is equivalent to 10x, and they tell us that the area is 100 units. So that means 100 units is equivalent to 10x in regards to this rectangle. So to figure out what this value of x is, I can divide both of these sides by 10. And I am left with x is going to be equivalent to 10. Because 100 divided by 10 is 10. So that means right here, 2x is the same thing as 2 times 10, which this means that that length is going to be equivalent to 20. So we're not done with the problem. They want us to find the perimeter. So to find the perimeter, I'm just going to now add up my 4 sides. I have 20 plus 20, because that means this side is now 20, and then 5 plus 5. And this is all going to be equivalent to 50. And whatever the units are, we can say units. So that means our perimeter is equivalent to 50 units. So this one was a little tedious because we had to use the area to figure out what x is equivalent to, so we could figure out what the length of this rectangle is. And then once we found the length, we added up our 4 sides to find the perimeter. So you're kind of taking what you know about perimeter and it's going into what I like to call X Games mode. It's a little bit more complex. So now that you've seen 3 examples of how we find perimeter, I'm going to have you guys practice some practice problems. There are 3 practice problems I would like for you to do. Please pay attention to how I say them so you know exactly kind of what to find in your Practice problem. So practice problem number 1 is they tell you that the shape is a rectangle, the perimeter is 500, and the length, the longest side, is 25. They want you to figure out what is the width. My suggestion would be to draw a picture of a rectangle and label your 2 lengths, and then use that to kind of help you set up an equation to solve for the width of the rectangle. Number 2, simply looking at this triangle, I want you to find the perimeter of this triangle. And then the third shape, this is what's called a composite shape that looks like they put a rectangle and a triangle next to each other, and they give you some measurements, and it wants you to find P, or the perimeter of the outer perimeter. So that means of this outer distance around the shape. It doesn't want you to find the perimeter of each shape and add them together. It wants the outer distance. Like, think about this, if this was like the size of your yard, if this outer distance, find the perimeter of it given the measurements that you have. Please make sure that you write down the examples, draw the photos or the pictures to help you. You can check your answers in the table of contents, and I hope you guys have a wonderful day. Bye.